So in this problem over here, we have a case of constant acceleration. How do we know this? We know this from the fact that the car is decelerating uniformly. So this part over here just means we have constant negative acceleration. Now, we want to split this problem into two parts because, first of all, we need to find out what this uniform acceleration is in this first part over here. So this is the first stage of the problem, and the second stage of the problem, we need to find out when the car actually comes to rest. So this part over here, second stage, and second stage, of course, we need to find out how much further it will travel, so the additional displacement it will need to come to rest. So first part, we want to find out acceleration. What is this equal to? Okay, so to find this out, what we need to do is state our initial variables. So we have u, that is 30 meters per second. Put in units when you can, just to check that everything checks out. So the final velocity is going to be 15 meters per second after a displacement of 75 meters. So this is our delta x, or we can just call it x, just in short. Okay, so we have these four variables over here. 3 are given, 1 is unknown. So we find an equation here. See that the fifth one contains all 4 of these, and this will allow us to find a. So before we actually move on, let's rearrange the fifth equation to make a the subject. Might make our lives a little bit easier. So we have a equal to b squared minus u squared divided by 2x. And if we sub in the numbers, we're going to end up with v squared, which is 15 squared minus u squared, it's 30 squared over 2 times 75. Okay, so I'll just scroll down here a little bit, plug that into my calculator right over here. So 15 squared minus 30 squared, what is that equal to? Divided by 2 and then divided by 75 as well. So that will give us an acceleration of negative 4.5. So the negative over here just means that we are decelerating. That's all it means. Okay, and once we know this, we can use this deceleration in the second part of our problem. So just going back up to see what we need. Now we need to know how much further it will travel. So that will be x, and that's our goal. And how much further it needs to travel to come to rest. This means that this information, the rest part, just means that our final velocity is going to be 0. Okay, so part 2 of the problem. What we need is to find x. We don't know this. We know that in the second stage of the problem, it's already decelerated down to 15 meters per second as our velocity. So this is our new initial velocity. We want it to come to rest. So the final velocity should be 0 meters per second. And our acceleration we know is negative 4.5 meters per second squared. Now over here, what relates all of these over here? Well, pretty much the same equation as we had before. This fifth equation over here. So the only difference in this problem is that we have x as our unknown. So rearranging this equation is going to give us x equal to b squared minus u squared divided by 2a. So we just transpose that using a bit of algebra. And over here, where we sub in all of our values, so we have u, b, and a plugged in, so we have 0 squared, of course that's still 0, minus 15 squared divided by 2, multiplied by negative 4.5. And what do we end up with over here? So we have negative 15 squared, so let's say 15 squared multiplied by -1. Just make our lives a bit easier. Oops, can't do that. Okay, so minus 15 squared. There we go. Okay, then divided by 2, and divided by 4.5, and I'll just take the negative version of this answer. So in the end, it looks like we have a displacement of 25 meters, or this is our additional displacement. Okay.